we shall discuss the solution of the questions of organic in JEE Main 2016 paper. This paper is code of the paper is code F, and question number 2, which belongs to organic chemistry, is 2-chloro-2-methyl pentane on reaction with sodium methoxide in methanol yields. There are 3 probable answer for the products. This is this is an ether, this is an alkene which belongs to Hoffman alkene, and this is Sidjeff alkene. Now let us go for the solution. Two-chloro-2-methyl pentane is a tertiary alkyl halide, and the reagents are a strong alkali, sodium methoxide in methanol. Now, strong alkali is basically the reagent which prefers E2 reaction for a tertiary alkyl chloride, and methanol is a PP solvent, polar protic solvent. Under the in the presence of polar protic solvent, SN1 reaction is preferred, especially in case when the alkyl halide is tertiary. So there are 2 probable reactions possible, E2 and SN1. In case when it is E2 reaction, then we will have 2 different products, 2 different alkenes. One is the one alkene and the other is the crowded one. So as far E2 products are concerned, we will get this kind of alkene, which is major alkene, major E2 product. This is major E2 product, plus which is called Sidjeff product also. It is Sidjeff's alkene as well, plus another product, another possible product is this one, which is minor E2 product. Also named as Hoffman alkene. As far as elimination reaction is concerned, these 2 products are possible, but since in question they have not mentioned that we have to report only the major product or minor product, so we have to report all the possible products. In case when it is methanol, SN1 reaction is also possible, in which there will be a carbocation after the removal of Cl minus, and at that carbocation, which is the most stable carbocation because it is tertiary, methanol will attack as a nucleophile to give OAME. This is an ether. So basically, out of all the proposed products A, B and C, all are possible in different proportions. As for the E2 reaction is concerned, elimination reaction is concerned, this C product C is the major one, product B is the minor one, and as for the SN1 reaction is concerned, product A is also possible in a very less proportion. So our answer in this question will be all of these. Okay? Now the next question of organic chemistry from the same paper, JEE Main 2016, code F, question number 4. The question is, which of the following statements about low density polythene is false? Low density polythene is a very weak kind of polymer, and polythenes are the polymer of ethylene, N molecule of ethylene, when undergoes polymerization, under high pressure and high temperature condition, then molecules of ethylene are getting added, and this is the structure of polyethylene, which is commonly known as polythene. And low density polythenes are weak, and they can be used only in the formation of polybags and other small things. One by one we shall go for the options. It is a poor conductor of electricity, that's true. all the plastic and polymers are poor conductors of electricity. So it is a true option, and it is not our answer because we have to find which one is false. Next is, its synthesis required dioxygen or a peroxide initiator as a catalyst. In polymerization reaction, when it is a free radical reaction, then peroxide initiators are required as a catalyst, or dioxygen is required as a catalyst, because they will initiate the reaction. Oxygen or peroxide, both are. Oxygen is initially an inhibitor, but finally it becomes initiator, so reaction becomes fast. And that's why this way option number 2 is also a true statement. It is not our answer. Option number 3 is, it is used in the manufacture of buckets, dustbins, etc. This is wrong answer, and this is our answer. This is the false statement. Why? Because low density polymers, low density polymers are very weak plastics, and they cannot be used for the preparation or for the manufacture of such items like buckets and dustbins, which require little strength. And the fourth option is synthesis requires high pressure. That's true. Polymerization reaction occurs under high pressure condition. So this way the answer of this question number 4 is third. The next question of organic chemistry from the same question paper, JEE Main 2016 code F. This is question number 8, which tells which of the following is an ionic detergent. The options are sodium lauryl sulfate, cetyl trimethyl ammonium bromide, glyceryl oleate, or sodium stearate. We will go for the structures of these different compounds, detergents. This is sodium lauryl sulfate. The structure is like this: CH3, CH2 whole 10, CH2, O, SO3 minus Na plus. It is an anionic detergent. Actually, detergents like this cetyl trimethyl ammonium bromide is a cationic detergent. When hydrophobic part is having negative charge, we say anionic detergent. When hydrophobic part has positive charge, it is called cationic detergent, right? So out of all these 4 options, option number 1 and option number 2 are detergents, and option number 3 and option number 4 are soaps. So the question asks, which is anionic detergent? And according to the question, the answer will be sodium lauryl sulfate. Whereas last 2 options are for the soaps, and that's why they don't cover the answer. Understand? So the answer of this question will be 1, which is an anionic detergent. The next question from organic chemistry in the same JEE Main 2016 code F paper is question number 10. The question is, the distillation technique most suited for separating glycerol from spent lye is first option, fractional distillation. Second option is steam distillation. Third option is distillation under reduced pressure, and the fourth option is simple distillation. Let me tell you what is spent lye. See, soap is manufactured in industry starting with some fats and oils, which are basically triglycerides. When triglycerides are reacted, triglycerides are basically fats and oils. When they are treated with strong alkali, caustic soda or sodium concentrated NaOH, right? Then these triglycerides, which are basically esters, triesters, they are broken into sodium salt of carboxylic acids, sodium salt of fatty acids, higher fatty acids. And as a byproduct, glycerol is also formed. Glycerol is basically propane 1,2,3 triol. Glycerol is also formed in the reaction along with the soap formation, soap manufacturing. This glycerol along with other impurity is present here. So soap is separated from the mixture, and the other impurity, in which glycerol is also dissolved almost by 10% of the proportion, that is called spent lye. In small scale industries, that is the waste, they discard it. But in big industries, what they do, they separate glycerol from that spent lye by distillation process, which is called under reduced pressure, distillation under reduced pressure, so that this 10% of glycerol is also used, they sell it in the market, and that's why they compensate their manufacturing cost. Now why under reduced pressure? Because organic compounds are having less boiling point, like glycerol has boiling point 290 degrees centigrade. If you distill it without any reduced pressure or without any vacuum, then what happens? These compounds which are having lower boiling points may get burnt, or their properties may get changed. Even there may be some chemical change. So what we do to distill it, to separate it safely, we distill it under reduced pressure, because under reduced pressure the boiling point of the compound also decreases. And this is why this distillation under reduced pressure is a safe distillation, safe separation. So glycerol from the spent lye is separated by distillation under reduced pressure. So answer of this question is 3. Next organic chemistry question in the same question paper, JEE Main 2016 Code F, is question number 14. The question is the absolute configuration of this compound. This compound has 2 chiral centers. There are 2 chiral centers, H, OH, and the other chiral center contains HCl and CH3. If we do the numbering of these carbons in the carbon chain, this is the first carbon, this one is second, this is third, and this one is fourth. In case when we are going to determine the configuration of chiral center, and suppose carbon number 2 is taken under consideration, then rest of the part of the molecule is just a group. If we go for a rough work, what can we do is, carbon number 2 is having COH upside, H at the left, OH at the right, and there is one group CHCl CH3. This part of the molecule will be considered as a group. Now we'll allot the priority. Out of all the 4 groups, according to CIP rule, first priority is given to OH group, and then second priority is given to this group, third priority to COH, and the fourth priority to H. Now if we hide fourth priority group and we go from 1 to 2 to 3, we see that it is S. So actually carbon number 2 in this molecule is having S configuration. Same way we can take out carbon number 3 in rough. What carbon number 3 contains is CH3 at the downside, Cl at right, H at the left, and upside there is one group having carbon with H, OH and COH. Now this part of the molecule is considered just as a group. Now allot the priority. 1 to this group, 2 to this group, this is 3, and fourth priority again is at the left in horizontal line. If we hide the fourth priority group and go 1 to 2 to 3, we see anti-clock rotation, that is R. That means carbon number 3 in the molecule has R configuration. That means the answer of this question is 1, 2S, 3R. The next question of organic chemistry in JEE Main 2016 Code F is question number 24. The question is, thiol group is present in, options are cysteine, cysteine, methionine and cytosine. Now the structures are like this. Cysteine is this one. Cysteine is basically the dimer of this compound where sulfur-sulfur single bond is present. Cysteine is having SH group, thiol group. This is our answer basically. This is amino acid having thiol group. Methionine is like this. This is having sulfur but not thiol. And cytosine is this compound, which is a cyclic compound. So our answer in this question is cysteine, the second answer. Cysteine is the answer. The question of JEE Main 2016 code F is question number 27, and the question is, in the Hofmann bromamide reaction, the number of moles of NaOH and Br2 used per mole of amine produced are. The first option is 4 moles of NaOH and 2 moles of Br2. Second option is 2 moles of NaOH and 2 moles of Br2. Third option is 4 moles of NaOH and 1 mole of Br2. And the fourth option is 1 mole of NaOH and 1 mole of Br2. Let us go for this Hofmann bromide reaction is basically, Hofmann bromide reaction is very good reaction for the preparation of primary amines, and pure primary amine is prepared by this method. What happens basically, any unsubstituted amide which is having CONH2 group, when treated with NaOH and Br2, NaOH and Br2, 4 moles of NaOH and 1 mole of Br2 are required, and it gives primary amine as the product. Pure primary amine is formed. That means there is no contamination of any secondary or tertiary amine in this method. The mechanism of this method is like this. Mechanism of this reaction is like this. What happens in first step, this base NaOH, OH minus takes away the acidic H of NH2 group to form this kind of anion of amide. This OH minus comes from NaOH and anion of amide is formed. This anion of amide attacks on bromine molecule. It is a nucleophilic attack. NaBr is out, and what we get is RCONHBr. This is called N-bromoamide. In this N-bromoamide, what happens basically, the other mole of NaOH takes away this second acidic H. H2O is out, and we get the salt of N-bromamide. This is the salt of N-bromamide. This is a salt, and a very good rearrangement occurs in this step. This is the slow step. This is RDS, in which what happens, this bromo goes off in the form of Br minus. So nitrogen becomes electron deficient. This nitrogen, this alkyl group at the carbon shifts. This is 1,2 alkyl shift, and this is a pure intramolecular shift in which even the configuration of this R group doesn't change. So the carbon becomes electron deficient. That's why this lone pair comes here to form a double bond. So NaBr is out in this rearrangement, and this compound becomes Rn double bond C double bond O. This is N-alkyl isocyanate. If we have methyl in presence of R, then that will be methyl isocyanate. In short, that gas is named as MIC, and MIC was responsible for Bhopal gas tragedy. And when this alkyl isocyanate is hydrolyzed, then it forms primary amine along with CO2. Understood? So this is the mechanism of this reaction. The next organic chemistry question of JEE Main 2016 code F is question number 29, and the question is, the reaction of propene with HOCl, hypochlorous acid, which is also written as Cl2 plus H2O, proceeds through the intermediate. In this question, according to my opinion, there is no correct answer. I'll explain first. Actually, propene is this. It is an alkene. An alkene with HOCl undergoes electrophilic addition reaction to form an addition product in which OH is at this carbon and Cl is at the outer carbon. Mechanism of this reaction is very simple. In any addition reaction, the reagents added are electrophile and nucleophile both, but the name of addition reaction may be either electrophilic addition or nucleophilic addition depending upon which reagent attacks in RDS. In this case, what happens actually, HOCl is an acid which is named as hypohalous acid. It is having H plus as well. So this HOCl gets protonated from its own protons to form this protonated HOCl. From this protonated HOCl, actually H2O is out and Cl plus is formed. Cl plus is the electrophile, and in second step this electrophile Cl plus attacks on alkene. Cl plus is a kind of electrophile which is having lone pair of electron as well. Now this alkene attacks on the electrophile. This is electrophilic addition. This is the RDS, rate determining step. So what happens actually, first of all, this electrophile is added on the outer side according to Morikonikov's rule, which says that electrophile comes on the alkene in such a manner so that it gives rise to a more stable carbocation and it forms a carbocation. But almost immediately or within no time, this lone pair of the electron extends and forms a cyclic chlorinium ion. So actually classical carbocation is not the intermediate in this reaction. Non-classical carbocation or cyclic chlorinium ion is the real intermediate of this reaction. And the further evidence that cyclic chlorinium ion is the intermediate of the reaction is that carbocations formed in this case of addition of HOCl do not rearrange. And in this intermediate, actually nucleophile H2O in a fast step attacks from the back side at the most stable position to give the product by removal of H plus. So this is the product. This is the product of this reaction, and real intermediate of the reaction is cyclic chlorinium ion. So according to my opinion, either this question should be kept in the bonus marking, or otherwise the most appropriate carbocation, if we can say, will be the first one. The next question of organic chemistry in JEE Main 2016 code F is question number 30. The question is, the product of the reaction given below is, the reaction is this cyclohexene ring which is having a tertiary butyl substituent. When it is treated first with NBS in UV light and followed by H2O in alkali, K2CO3, alkaline hydrolysis, then what will be the product? Actually what happens, NBS is very specific reagent for bromination at any allylic position. NBS is very specific for bromination at any allylic position. So in first step there are two allylic positions, this one and this one, and free radicals are formed. The intermediate of this reaction is formation of free radical. Either this free radical or that free radical will be formed. This free radical will be formed, but this free radical is more stable. This free radical is more stable, so it will be formed preferably. This free radical is more stable, so it will be formed preferably, and this free radical may undergo resonance. So we will have both these free radicals. They are the resonating structures of one real hybrid, and then finally we'll get this kind of two bromo products. One is this and the other is corresponding to both the resonating structures. These are two brominated product by NBS, and when this product is hydrolyzed in presence of weak alkaline water, then we'll get OH in presence in the place of Br by SN1 reaction. So we can get these two alcohols, OH and this OH. So the answer of this question is option 1.